Welcome back, engineers. In our last lesson, we learned how switches and buttons can let us control whether a circuit is on or off. But what if you wanted to control how much electricity flows, not just stop or start it completely? We're going to start off with a problem to solve today. Using your battery, LED and resistor, wires, and any other blocks in your spark block kit, try to create a circuit where the LED can shine at either full brightness or dimmer without replacing any components along the way. Welcome back. What were some of the challenges you encountered during this build? Were you able to make it dimmer with just the pieces in the kit? Or do we need to do a little bit more learning so we can figure out how to do it? One of the problems you might have encountered is that each of the components that we've learned about so far has the same voltage drop. We can't reduce the power to the LED unless we introduce something new or take something away. Engineers often need to control not just when the power is off or on, but sometimes how much power the circuit will receive at any point. That's where variable controls come in. By the end of this video, you'll be able to explain what variable controls are and how they work, explain the similarities and differences between switches and variable controls, and solve problems by using variable controls. A resistor reduces the flow of electricity by causing a voltage drop, which lowers the amount of power available for the other components. A variable resistor is just a resistor you can adjust. You can change how much the voltage drops while the circuit is running. There's a few different variable control components that you can get, but the ones we'll discuss here are the photoresistor, the potentiometer, and the rheostat. The SparkBlocks kit doesn't have a rheostat in it, but the potentiometer can be hooked up and used as one. Potentiometers and rheostats are pretty similar. They're both kind of like volume knobs. Turn it one way and the resistance goes up. Turn it the other way, the resistance goes down. Photoresistors change the amount of resistance depending on how much light it sees. With a flashlight on it, the resistance goes down. Covering it with your hand, and the resistance will go up. Both are types of variable resistors, but they both respond to different kinds of input, one by twisting, the other using light. Potentiometers and rheostats are both very similar. There's a lot of confusion between them. So let's take a close look to see what the differences between them are. If we look inside to see how the two components work, we'll see that they're actually very similar. They both have a resistor material that's connected to the input, and a wiper arm that drags across it when you turn the dial. A rheostat has only those two connections, but a potentiometer has another at the end of the resistor material. The terminal at the end is designed to connect to the ground. This creates a parallel section of the circuit which divides the power. Because of this division, it's often called a voltage divider. You can see the difference in the terminals on the electrical symbols too. A rheostat has two connections, a potentiometer has three. Let's go ahead and build a circuit to see how the potentiometer works. We'll use the motor and control the speed with the potentiometer. Start, of course, with the battery and connect it to the potentiometer terminals for ground and power, of course, using the correct wire colors. We can now connect the motor to the wiper and then back to ground using the same color wires for each side. Using the dial, we can change the speed of the motor and make it slower or bring the speed back up to what it was before. You might notice that we can't make the motor faster than it is when we connect it directly to the battery. That's because the potentiometer can only decrease the voltage going to the motor, but it can't add any more volts than the 3.7 coming from the battery. Now let's go ahead and replace that motor with an LED. We can control the brightness of the LED the exact same way. Just turn the dial left and right. Next up, we're going to connect our potentiometer as a rheostat. Before doing that, we're going to turn the brightness of our LED down so it just turns off. Now that we've got that LED barely off, let's go ahead and connect this as a rheostat. To do this, we're going to disconnect the return wire from the potentiometer, and we're going to bypass that potentiometer using the wire in place of it. The potentiometer will go ahead and flip around, And we'll just connect those two terminals on the power side. If you look closely before touching that dial, you should see that that LED is powered on even without touching it. And that's because the power is distributed differently when it's connected as a rheostat instead of a potentiometer. This gives our electricity only one path to go that can be controlled using this dial. The other type of variable resistor we have is called a photoresistor. Personally, I think photoresistors are one of the most interesting components in the SparkBlocks kit. The purpose is to decrease resistance as light increases, meaning when the component sees light, it allows more current to flow. The way they work, though, is really the interesting part. Inside the photoresistor is a conductor material. The atoms in that material have electrons at a low energy state. That low energy state makes it difficult for current to flow through it because the electrons can't move very freely. That makes it not a great conductor material. But when light energy in the form of photons hit the material, it makes the electrons excited and they can move around more freely. This allows the current to flow better through the material and therefore through the circuit. The more light that's available, the more excited the electrons are and the more energy they have. When the light goes away, though, the electrons calm back down to their low energy state, and it's again hard for the electricity to flow. Now let's go ahead and try the photoresistor together. Building this circuit here, what do you think will happen if I shine a flashlight on the photoresistor? What about if I cover it with my hand? Go ahead and pause and make your prediction. Now let's go ahead and test it. If we allow a lot of light into the photoresistor, that LED is going to get really bright. If we cover it up, the LED is going to dim until it turns off completely. This concept, along with some other components, is why nightlights and streetlights use photoresistors. They automatically respond to changes in the environment by measuring the amount of light. Way to go! Let's review what we learned today. We learned what variable resistors are with specific examples of potentiometers and photoresistors. We compared switches and variable resistors using a double bubble map. We also analyzed circuit diagrams featuring variable resistors and explained how changes to their input will impact the function of their circuits. Next time you twist a knob, the brightness of a screen automatically adjusts, or you see a light turn on at night, you'll know that the variable resistor is probably making it happen.